Hello, everyone. This is Nick Orlov, and welcome to GCP Live. Today, we'll be talking about some exciting concepts on machine learning and big data, favorite for everyone. As you know, my name is Nick Orlov, and I'm a customer engineer with Google, helping with all things cloud. And with me is Corey Peel. Corey, you want to introduce yourself real quick?
Yes. Hi, I'm Corey Peel. I'm also a Google Cloud customer engineer. And this is going to be a really exciting topic, talking to some people who've really done a lot of work on the GCP platform, and really exciting to get started.
Yeah, exactly. So let me hand it over to a couple of our co-hosts. Basically, we have Aviv and Vadim from DoiT International. They are a customer as well as a partner. So Aviv, you want to introduce yourself real quick? Just a little bit of a background and what it is you guys do at DoiT.
Yeah. My name is Aviv Laufer. I'm part of the CRE team at DoiT. I've been doing this software stuff for the past 25 years, mostly in CTO and VP engineering roles in companies like Shopping.com, Finjan, SuperDerivatives, Rounds, and Cybereason. And now I'm helping customers with my experience to better use the cloud.
Awesome. Very cool. And Vadim, you want to introduce yourself as well?
Yeah, sure. So my name is Vadim. I'm the CTO of DoiT International. So I'm working basically on the same team as Aviv. We are both customer reliability engineers. So we are sharing our experience and knowledge on Google Cloud Platform with our customers.
Awesome. Very cool. So you mentioned customer reliability engineers. I think that comes into two different parts. One is obviously the reliability and the uptime of your applications, whether they're running on cloud or on premise. But then the second piece, I think, is running those applications responsibly, which definitely plays into the cost of those applications. So really what we're here today to talk about is some of the awesome machine learning advances that you've done on your reOptimize tool. So Vadim, maybe you can step us through kind of what reOptimize is, what the goal is, and maybe how it used to be modeled before you switched over to machine learning.
Right. Yes. So, since we work for a really long time with many Google Cloud Platform customers worldwide, several years ago, we recognized the need for a tool that will help our customers to better analyze their spend with Google Cloud Platform. Because exactly as you said, it's not only about engineering, but it's also about how to do that in a cost-efficient way. And in order for you to enable or to be able to use the platform in a cost-efficient way, you need first to understand your spend. You need to understand what product you are using and what you can optimize in terms of that use. So several years ago, we started to develop a tool. It's called reOptimize. It kind of helps you to optimize your cloud spend. And I'm going to give you a short walkthrough, so how it looks and what it does.
Awesome.
So I guess you can see my dashboard, right?
Yes, we can.
Okay, awesome. So this is the main dashboard of reOptimize. So I'm logged in as a customer, so I can see on a glance that I can see the spend, my spend with Google Cloud Platform over several last months. I can see November, December, January, and February. I can see how my spend is being split over different products. So I can see that I'm overall paying about 45% of my cloud spend is Google Compute Network. And then instances are another 34%. And then I have some spend with BigQuery and Cloud CDN. And I can go in and drill into my data and see, okay, in my network spend, how much is from North America to North America, how is to EMEA, and etc. So I can get that really quick view on how my spend looks like. And I can also take a look breakdown by projects or breakdown by services, or I can go and filter by projects or by labels or by something that we call cost allocations, which are basically groups of labels. And here at the bottom, I can see my spend over the daily resolution of my spend. So I can see how much I'm spending every day and on what products, and I can also compare that to the previous month. So I can understand more or less how far off I am from the same day on the previous month, and it sometimes helps me to understand if I'm using the platform right, or maybe I'm doing something wrong. And on top of that, you can do a bunch of additional things. You can manage your budgets. So, for example, in my example here, I have two budgets, one for production and one for staging. So I'm allocating some sort of a fund for a budget, and then I can see my progress towards the budget. I can see that I'm already overspent my staging budget, for example. And then I can go and have more in-depth analysis with what we call a pivot builder, which is basically you can slice and dice your billing information. So, for example, here, once again, I can see like how different products correlate one with another over time, and I can go and do like some additional visualization. I can like do a tree map, for example, or I can do like a raw table, and I can download the information to a CSV file or share it with a Google Drive. So I can do like a lot of stuff here. And finally, we have something that we call optimizations. So optimizations help me to, as I said, optimize my spend. So for example, I can go and check and see, okay, if I'm going to purchase, in this example, some committed use discounts, I can save, well, about $130,000 over the course of the next year. And I can, of course, play here with the numbers and find the model that will work for me best. So this is reOptimize in a nutshell. And one of the things that it was like a top priority on the wish list from our customers. It was, okay, we are now starting, for example, March 2018, and how can I know what would be the amount that I would be charged by Google by the end of the month?
Yep, absolutely.
Yes, and initially I will show you first of all how it looks like in our system. So I'll switch to March 2018, and then you can see that my current spend, like my real spend, is $8,300. But there is like also this part, which is like lighter part of the chart, which says my estimated spend is going to be additional $32,000 approximately. And this really a very powerful tool for many of our customers, because it gives them a confidence because many of them are like organizations that are running on budget, so they need to forecast their spend, and the sooner they have the forecast, it's better. So most of the time today we're going to spend talking about, okay, so how we are actually able to kind of predict how exactly the month is going to finish in terms of the cloud billing. And initially, when we first implemented that feature, we basically did like a very trivial linear regression, right? So we took like a daily average of a specific customer, and then we just extrapolated the cost over the course of the remaining days of that month. And we got some results, right? So unfortunately, while it technically worked, but in terms of the accuracy, it wasn't very accurate.
Yeah.
And I mean, it's really, like if you think about that, it's really, you can understand why it even cannot be accurate, right? Because there is some seasonality. Sometimes on some certain days of the week, I might be getting more customers because maybe I'm in retail or e-commerce business, or it really depends on the kind of like a mixture of the Google Cloud product that I'm using, right? Because not all products have like linear cost. Some of the products, for example, like Google Cloud Storage or Google Cloud Network, they have a tiered cost, right? So you pay a certain amount per gigabyte, for example, up to 1 terabyte a month. But if you go like from 1 terabyte to 10 terabytes, it's a different cost. So it's like really complicated to formulate all of those like little pieces of the puzzle into a single formula. So after a while, we started to think about, okay, how we can basically predict, like based on machine learning, the overall spend of a customer. And we can, we're going to share like the secret sauce today of how we're doing that. And even with our machine model, we went through several iterations. So we had something in the beginning which kind of worked, but again, it was not, I mean, it was machine learning, but it wasn't very accurate. And over the time, we did additional like feature engineering, and we tried to experiment and understand what exactly will give us like the most precise result here.
Yeah, absolutely. And just before you jump into some of the secret sauce, how familiar were you with machine learning before you got started? I mean, building a linear model isn't too complex. There's a lot of variables that do get fed into that formula. But from a machine learning standpoint, did you come into it with a pretty decent understanding, or did you have to teach yourself along the way?
Well, basically, when we first kind of like told ourselves, okay, let's try the machine learning thing, we didn't know a lot about machine learning in general. And luckily for us, we came across a Google article, which I remember the title. It was Machine Learning Without PhD.
Nice. I like that one.
Yeah, and it really like helped us and give us the courage to kind of like to try that. So we are by any means, we are not mathematicians. We don't have a long history of the machine learning experience, but we said, okay, we are software engineers. We should be smart guys, so let's try to figure it out. So answering your questions, a couple of years ago when we started to use machine learning for prediction, we didn't know a lot about that. But I think we like really understand it today. Like we see like how many mistakes we did over the course of the time. But I mean, it wasn't as hard as we imagined. Okay, and this is like really the message here. I mean, sometimes people hear machine learning and they try to imagine some like really complicated like stuff and many like really smart PhDs working on developing a model. So we didn't have the PhD degree, any of us, and but we still could figure it out. So with help of TensorFlow and specifically CloudML, it was like completely doable by us.
Man, that's really encouraging.
Yes, definitely. And then also, because of the nature of the models you were building, you were able to leverage your background in site reliability engineering, but also your experience and insight into the way the Google Cloud Platform operates and the pricing models as well. So just wanted to see if you were also getting any additional resources focused specifically on the way you would model the pricing or consumption, since we do update our pricing models every once in a while.
That's a valid question.
Yes, yes.
Yes, and actually this is when the machine learning shines, right? Because if we hadn't have developed that model, so it means that every time that Google is updating the pricing, we should kind of like refine our formula or refine our prediction algorithm. But the way it works today, it's like completely automatic. Great. So it just learns the new data, and as long as, I mean, as soon as the new data comes in and we have enough of the new data, we kind of like automatically detect the change, and then we start to predict more precisely the end of month billings.
Great.
Cool. Yeah, and one of the challenges that we had, as probably, I guess, many people know, your model will be more successful if you have a lot of information, right? I mean, if you can feed like tons of data, it will probably almost always benefit your model. And luckily for us, we not only had our own billing information, but we already had reOptimize. And reOptimize today is serving about 20,000 organizations worldwide. So we really had a lot of billing data. So we could experiment. And of course, well, machine learning, it's not only science, but it's also an art, right? You need to do a lot of experiments. And luckily for us, with CloudML, those experiments aren't very expensive. So it gave us an opportunity to like do a lot of variations of our model until we really found like the right amount of every feature in our model and how we express certain pieces of information that we can extract from the billing information.
Cool. So should we go through that architecture then?
Yes. So what we actually have here, so reOptimize runs on Google App Engine. So this is that. And then our data is actually coming from Google BigQuery. So in order to work with reOptimize, our customer need to go to their billing account and to configure BigQuery billing exports. And this is the way that we are getting the information. On top of that, I mean, the billing exports to BigQuery, it's relatively new feature. It was graduated to general availability, I would say probably like 4 or 5 months ago. And before that, people could configure their exports to just a Google Cloud Storage bucket. So we are getting the information from actually 2 sources. One time from the Google BigQuery, it's a new data, but we have like terabytes and terabytes of information, of legacy billing information stored on Google Cloud Storage. And so our architecture actually takes into account like both of those sources. So Google Cloud Storage data goes through Google Dataproc. We are running part of our model, and we are doing some enrichment with Dataproc, specifically with Spark and with MLlib. And then we have the model itself running on CloudML. So for people who are not familiar with CloudML, it's basically a managed TensorFlow. TensorFlow is a Google machine learning framework. It's a great piece of architecture or infrastructure, I would say, which allows you to run your model in a very, I would say, easy and scalable way. Because once again, we are retraining our model every day. And the amount of data that our customers' billing files are generating is today about 50 terabytes of data. So in order for our model to be able to learn 50 terabytes of data, we need something scalable. So we had 2 choices here. Either go and deploy our own TensorFlow. It's open source. We can theoretically deploy it on our Google Compute Engine instances and handle ourselves, the auto-scaling and the log collection and monitoring and high availability and attaching GPUs and doing like all that. Or we could just use CloudML. So we are using TensorFlow as a service, I would say, and it does everything automatically for us. It scales, it's monitored, so we are getting our monitoring data into the Stackdriver, and we don't need to kind of patch our system or deploy new versions of TensorFlow as they come out. So CloudML for us, it was like a really easy choice, and we are, I mean, the whole reason that we are running reOptimize on Google App Engine and that we want, I would say, like ops less, like no ops operation. We don't want to spend our time on issues like scaling or monitoring or making our system highly available. So the same idea goes with machine learning. We don't want to do those things by ourselves, so we are using CloudML. And once we have trained our model, we are pushing the data through task queues to Google Cloud PubSub, which is kind of like a messaging infrastructure. It's a publisher-subscriber. And then it goes through Cloud Dataflow, where we are joining the information from both BigQuery and Google Cloud Storage. And finally, it goes back like the whole cycle. So as I said earlier, we are retraining our model every day. And well, we could, I mean, one of the things that that allowed us to make our model more exact or more precise, it's we kind of try to correlate the data between that is coming from different customers. So we can find patterns and we can learn how the normal spend should look like, and then we can do like really smart things with that. For example, if you are reOptimize customer and you're using reOptimize, we will like send you an email with an alert and say, well, we have compared your spend with like other customers, of course anonymously, and we have detected some sort of abnormal use. We think your cloud billing is too high or too low, and we advise you to take a look on that and see maybe you are doing something wrong. And those kind of things, we couldn't do them without the machine learning, because the amount of data is huge, and I mean, there is no way we can predict all of those things, you know, with just a simple like a linear regression or a formula. So it's not only helping us to predict how the billing will look like by the end of the month, but we can also do like smarter things like those alerts, or we can we have some things that, for example, you are using certain product, maybe Google Spanner or anything else, and then we can detect that your spend is going like way above the average that we see over the same type of customers that are using the same mixture of Google Cloud products. So we can give you a heads up and say, well, please take a look. Maybe your cluster is too big, or maybe you can use like a different type of disks, or maybe you can, if you have too much network traffic between regions, maybe you should like re-architect your application. So it's gone way beyond the only end of month predictions.
So in your application, it sounds like you added quite a bit of features to it. And what I guess I'm most interested in is you've had to transform your existing application and the traditional linear regression model. So when you were thinking that through, did you feel like you had to rewrite your application, or were you able to kind of modify it with some simple additions and modifications?
Well, that's a great question. Basically, we have to change very little in reOptimize because the whole machine learning part it's kind of like a little bit separated from our application. So we could build it like aside, and it's really like detachable from reOptimize. It's probably reminds kind of like a microservices architecture where each part is independent from the other part. So of course they are all communicating, but CloudML can read data from Google Cloud Storage. It can read data from Google BigQuery. So all of the wiring is already there. So we really could focus specifically on developing our model and making it more accurate. But I think that over the course of the last couple of years, we probably didn't spend more than, I would say, several days, maybe top, on infrastructure of our application. I mean, like 99% of our time we are spending on refining the model and actually experimenting with our model so we can find more use cases. And frankly, at the beginning, we just wanted to predict the end of month billing. But as we started to use the technology, we really kind of like realized the potential. And that's what gave us like an appetite for more. So we started to think, well, we can do more things with machine learning. We can detect abnormal use. We can like give advice on optimization or on re-architecting the application in a smarter or more cost-efficient way.
And also, I think it's really interesting if we're able to help some of your customers get the power of information to understand what's the best way to leverage committed use discounts and other options to significantly lower their GCP bill, especially if they're operating in a steady state. So it sounds like you have some people who are able to use this not just to predict end of month, but also to bring that information to their respective Google Cloud customer engineers and to help them get some additional discounts and have an understanding of what does that commitment really look like.
Oh yes, I mean we kind of have we see how our customers are using reOptimize over time, and what we have seen over time that every customer who is using reOptimize, they start to save money because we are able to detect those pieces of their infrastructure that might be optimized in some way, for example, by using the commit discounts or by sustained usage discounts or by some other things that you can do with Google Cloud Platform. And we have awesome customers. I mean, we have a huge list of requested features, and some of our customers they are amazing in terms of the ideas that they give us. So we are finding new applications for machine learning basically every day.
That's awesome.
Yeah,
very
great.
cool. Well, thank you so much, Vadim. I definitely appreciate all the walkthrough. For our dedicated listeners out there who may have seen our live stream with you guys about a month ago, we had some video and audio issues, and so we saved the topic that we covered then to recover part of it now, and that is BQTop. So Vadim, any last minute words that you want to chat about for reOptimize before we kind of transition into the big data and BQTop space?
Yes, so probably the only part that I would like to say, reOptimize is free of charge. It's on Google Cloud Launcher, so everybody can go there and just start using that and start saving with on their Google Cloud Platform bill.
Cool, man, that is awesome. Very cool. So great. So let's go ahead and transition a little bit to Aviv. So Aviv, thank you for being willing to join us yet again. Would you mind taking just a minute and chatting about BQTop, what the goal is, and what you set out to do?
Yeah, as Vadim said, we've got a nice amount of customers, and most of them are using BigQuery, which is a great tool, but some functionality is lacking. You don't know how many queries are currently running, which one are taking a long time, which ones are taking short time, and we wanted to create a nice small tool and that will help you visualize what is currently running your BigQuery. And there are two things that we're trying to do with all of our open source tools. The first thing is to give value to the users, and the second to demonstrate how easy it is to build those tools on the Google platform. So the first tool that we created, I'll share my screen, called BQTop. It basically gives you a visualization of currently running queries inside BigQuery. You can see that queries are coming and going, and you can see the queries that has been running in the last 24 hours. And there is a web-based UI for it, and also top-like Linux command line UI that you can run it on your machine. BQTop was built upon Google App Engine, and this is the architecture of BQTop. Basically, we're using the export of the logs from BigQuery using Stackdriver, creating a sink that will put the logs into Cloud PubSub queues. We've got two queues, one for starting of a job and another one for ending of a job. From there, we have a Cloud function that listens to those queues, get the data, and put it inside a Firebase real-time database. The reason that we put it inside a real-time database is because we didn't want that the front end, whichever will be, will constantly be pulling the data to know something started, something ended, but getting a real-time notification. This is one of the benefits of using Firebase is you can get a real-time notification on any action on the database, basically whether the data is added, data is deleted, or updated. So we have a function that listens from the incoming queue and can display when a job starts. When we get the signal that the job ends, then we take it out from the running table and put it into the finished job table. Yeah. It took us about, I don't know, probably 20 lines of codes to do that. The code is available on GitHub, of course, on the DoiT INTL/BQTop. We'll have to hear your opinions. It was very easy to write it. Again, Firebase, no ops at all, no scaling issues. And there's the server side, and we're providing two different UI. One of them is web-based, that is running as a Firebase Angular application. And the other one is running a local Python using ncurses to display it on your local machine.
Yeah, I absolutely love that you built this as a serverless application, just running some of the tools that are 100% managed by Google, just so much less of an operational requirement on your part. So that's really awesome. And thank you so much for making this code open source. On this YouTube video, we have linked both the blogs for the reOptimize as well as the BQTop, and we posted the GitHub link to the BQTop. And lastly, we have for anyone else who's interested in kind of getting their hands wet with machine learning, I also posted a link to one of the new machine learning training and boot camps out there, which is free for anyone to watch and learn, because you guys are absolutely right. Machine learning is definitely the wave of the future, and it's not as difficult as one might think, teaching a machine. So very cool.
Also, we released in the last couple of weeks, we released 2 additional open source projects, also serverless.
Oh.
One of them is if you're using a Datapro cluster, which is a great service, but no auto scaling up until now. So we created a tool, again, serverless, that can monitor a cluster and based on your rules, add or remove machines based on usage. They can be preemptible machines or normal machines. This is one project that is open source. And the other one is scheduling for GC instances. Basically, if you have development machines, most of the time you're not using them, not during the night, not during the weekend, and you can save up to 60% of the cost by using scheduling. So this is also released under our GitHub. Again, 2 open source projects built upon Google App Engine.
That's great.
Man, that is cool. That's the best part about being an open cloud is everyone can help contribute and make things better. So that is really cool. Well, anything, Corey, that you want to add in? Any last questions?
Oh, yeah. Well, I just wanted to thank you for keeping the perspective of site reliability engineers in mind, because you are providing tools and making them available so people can really get inside and optimize the environment. So thanks for continuing to do that. And let us know when you are putting together some new projects. It's really exciting stuff.
Yeah, we are definitely happy to chat about them. So
we definitely will.
Awesome. Well, thank you so much to our friends at DoiT. Really appreciate the time. Thank you for all our viewers out there watching this. So please remember to rate and subscribe to the YouTube channel or find us on meetup.com. And until next time, search on. Thanks so much, everyone.
Thank you.